Welcome back. In the previous video, we looked at definition 6.4.3 and saw the formal expressions for the cofactor expansions along rows and columns of A. In this video, we're going to look at a method that is more practical to calculating a cofactor expansion, and we're going to use that method in example 6.4.4. So we're not going to read the method first because there's really no point. We're going to read it as we go through and apply it in this example. So let A be this matrix that's given here. We're asked to evaluate the cofactor expansions along row 2 and column 1, and then to find the determinant of A using Sarris's rule. And then we'll compare these three values. So the method that we're going to use here is cofactor expansion. It says choose a row or column for the expansion. Well, we're asked to do this along row 2, so that is our choice. So that is the first step done. The second, identify the sign, the plus and minuses in the grid of plus and minuses that we talked about in a previous video. So what I like to do is I like to write my grid directly in the matrix. I know that the top left corner is always plus. So I start from there and I alternate. Now I'm not going to fill up the entire matrix with the plus and minuses. I'm only going to do where I need to go. I need row 2. So I'm going to work my way down to row 2. If this is a plus, then the next one down is a minus. Then I need to work across this row and I'm going to alternate. Right? So if I start with a minus, this is a plus and this is a minus. So I've got the pluses and minuses that I need for row 2. So that's the second step done. Now this third step is set up the minor that corresponds to the first entry. So the first entry is here. The minor is when I delete the row and column that entry is in. So the minor is going to be the determinant of the matrix that is left. And so we're looking at the minor as the determinant of 1, minus 2, 3. So the third setup is done. We've set up the minor that corresponds to the first entry in our row. Now we're asked to multiply the sign. Well, the sign of that entry is this minus 1. So we're going to take this minus and multiply that by the entry itself. Well, the entry is the minus 1, right? That's the row and column that we deleted was the entry of that first row 2. So minus 1 times that minor. Fourth step done. Move on to the next entry in the chosen row and then repeat. So we've done this entry, we're moving on to this entry. And so what we do is we set up the minor for this entry. So that minor means we delete the row and column that is in. So we've got 2, minus 1, 2, 3. So 2, minus 1, 2, 3. And then we do the same thing. We take the sign of our entry. Well, our sign here is now positive. So we're going to do positive and multiply by the entry. So 3. And now you see we're building up a sum. And so that says add this new term to the previous term and repeat for all the entries. Well, so we've only got one more, but if we had more, we'd continue all the way across. So the last thing is the last entry here. We're going to delete the row and column that it's in. So if we delete that row and column, we're left with 2, 1, 2, minus 2, 2, 1, 2, minus 2, and then the sign is negative. And I'm going to have 0 times it because 0 is that entry. So look what we have here. We've got the entry, the minus 1, times the minor. Then we have plus the entry, plus the 3, times the minor when we delete the row and column of that entry. And then minus the entry times the minor with a bracket, with a vertical bar missing, right? Minus the entry times the minor. Next step, now that we've got all of the terms set up, we're going to evaluate all these minors and add up the expression, right? So now this is something that we can perfectly evaluate. This is the cofactor expansion. Remember, each of these things is a cofactor, right? This is C, what row am I in? C2, 1, right? That's this part. This is a cofactor as well. This is C2, 2, and etc., etc. So this is the expansion of the cofactors. Well, this part isn't, right? This is the cofactor. I should be a little bit careful. This is the entry times the cofactor. So let's multiply this all out. So we're going to have minus 1 times 1. That's just going to be 1 times our determinant, which is AD minus BC. So we've got 3 minus 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 3 minus 2 plus 3 times, again, AD minus BC. So we've got 6 minus minus is plus 2, and then minus 0, and I really don't need to do the last part here because it's going to get multiplied by 0 anyway, so we'll just leave that as 0. So this gives me 1 times 3 minus 2 is 1, plus 3 times 8 is 1, plus 24 is 25. So the cofactor expansion along row 2 is 25. This is the cofactor expansion, along row 2. So that's the first part of what we were asked. That was the first part along row 2. We're going to do the same thing down column 1 now. So down column 1, which is this column here. We're going to do the exact same process down that column for practice, but also because we're asked to see what that gives us. We're asked to compare these values. So we're going to do down that column, which means I need to choose the row or column. Well, that's done. I've been asked to do it along column 1. I have to find the grid. Trying to start too many sentences at once there. I have to find the grid of plus and minuses for that column. Well, they're almost all there. The plus is on the top left corner. Then they alternate, so plus, minus, plus. That's all I need for column 1. I could fill out the entire grid if I wanted to, but I don't need to, so I'm not going to. Then I'm going to take, so the sign, which is this plus to start with, plus 2. So I'm going to do this, plus the sign times the entry times the minor. And the minor, I delete the row and column that the entry is in. So my minor is sitting right there, 3, 0, minus 2, 3. 3, 0, minus 2, 3. And then I move down to the next entry here. I have minus, minus 1. So minus, minus 1 times the minor. And again, delete the row and column that entry is in. My minor is 1 minus 2, 3, or rather the determinant of it. 1 minus 2, 3. And lastly, plus times the entry, so plus 2 times the minor, delete the row and column of that entry. That gives me this matrix, 1 minus 1, 3, 0. So the determinant of 1 minus 1, 3, and 0, and now I have an expression that I can expand along. So here, this is going to be 2 times AD minus BC, 9 minus 0. Minus minus gives me plus 1, I'm not going to write that, times 3 minus minus minus, so 3 minus 2, plus 2 times, and then I have 0 minus minus is 1, plus 3, 2 minus, I don't know what I said there. I get 0 plus 3. So we end up by getting 2 times 9 is 18, plus 1 plus 6. 18 plus 1 is 19, plus 6 is 25. Right? There is the cofactor expansion, down column 1. Now you might notice that is the same number that we got up here, and that is probably not a coincidence, but we are asked to do one more thing, and so let's reserve judgment. We need to find the determinant of A using Sarris's rule. Do we have any bets on what we're going to get? My money's on 25, but I might be a little bit, I might have some prior knowledge that would, like inside trading. I shouldn't be allowed to bet on this. So let's take a look. We're going to have the determinant of this matrix. So I want to have the determinant of 2, 1, minus 1, minus 1, 3, 0, and 2, minus 2, 3. Okay, I'll scroll up here. So Sarris's rule, we're going to recopy 2, minus 1, 2, 1, 3, minus 2, and do our basket weaving. So we've got 3 times 3 is 9, times 2 is 18, plus 0, and then I've got 3 minuses, so minus 2. and then minus the other way. So we've got -6, and then we have a 0, and then we have -3. So 18 minus 2 is 16, and then we have minus 9. 16 plus 9 is 25, and what do you know? Ding, 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 same value for all of them. So we're asked to compare, and our little conclusion should be all 3 values are the same. So is that a coincidence? I think not. In the next video, we will see a theorem which tells us, in fact, no, that it is not a coincidence. And this cofactor expansion is actually something that can work on any size matrix. It may be multiple steps in it, but we can see in the next theorem, in the next video, that this cofactor expansion will be what will serve for us as the general definition of the determinant. See you in just a moment.